Every single day, we reach out, grasp a handle, and turn a key. It's an interaction so routine, we rarely give it a second thought. It is easy to assume the hardware making this possible is stuck in the past, a relic of basic mechanical engineering and traditional metallurgy forged on an anvil. This scale comparison chart plots standard assumptions of the industry's economic footprint against reality. In 2025 alone, the architectural hardware market reached a valuation of $72.4 billion. As buildings become smarter, that number is projected to climb, reaching $115.8 billion by 2034. Dissecting this hidden anatomy requires looking past the polished metal surface to see how the modern threshold actually functions. We begin with the brain of the operation. Modern hardware is defined by an industry shift toward digital integration and smart access control. Looking at this market breakdown chart, we can see the global smart access control segment alone exceeded $9.8 billion in 2025. Major manufacturers are embedding traditional locking mechanisms with the Internet of Things to exchange data. This network topology diagram maps how individual smart locks act as nodes, connecting to a centralized building management system. By tracking real-time occupancy analytics, this system automatically adjusts lighting and HVAC distribution, improving a building's energy efficiency. These thresholds now function as active, data-harvesting security nodes. But digital brains still require a physical skeleton, the raw structural materials encasing these electronic networks. This pie chart details the raw materials in play. Despite the digital revolution, heavy metal dominates the industry with a 58.7% revenue share. Stainless steel and aluminum remain the primary choices here, providing the structural strength required for heavy commercial infrastructure. Sourcing these metals is changing due to strict green building certifications like LEED and BREEAM, which are international standards used to rate the environmental impact of construction projects. To meet these environmental guidelines, developers are generating demand for eco-friendly, recyclable metals manufactured with low-emission coatings. This line graph plots the cost of raw stainless steel and brass over time. There are frequent price spikes that directly correlate with ongoing global supply chain delays. Hardware manufacturers find themselves caught in a constant tension between fulfilling green building mandates and navigating unpredictable raw material economics. That brings us to the skin, the aesthetic finishes, textures, and exterior design trends driving purchases. A market paradox has emerged. As technology becomes invisible, consumers are seeking heavy, physical hardware. There is a resurgence of warm, traditional materials, specifically the return of brass to modern interiors. Aesthetic finishes are evolving, shifting away from flat black toward deeper graphite and oil-rubbed bronze. Textured finishes, like knurled, hammered, and ribbed surfaces, are sought after for visual depth and grip. On front entries, oversized poles and extended lever sets are being utilized to create a sense of architectural scale and presence. These heavy aesthetics act as a physical anchor, providing tactile reassurance in spaces run by invisible technology. Modern hardware is absorbing the digital future without abandoning its mechanical past. High-tech biometric capabilities are now physically protected by sustainable, textured metal casings. The industry's projected climb to $115 billion is proof of this marriage between old-world structure and new-world function. As buildings become more intelligent, the market increasingly relies on this physical, tactile connection to keep a high-tech world grounded.